Hello, my friends, data scientists, data analysts. Today, I am starting a new series. It is a machine learning series. I believe it is important to start machine learning after we have had lessons in regression analysis. We have had lessons in simple linear regression, simple linear regression, as well as multiple linear regression, and we have had lessons on transformations of models and all ins and outs of model, assumptions of modules, problems with the modules, how can the problems be solved, problems of heteroscedasticity, problems of multicollinearity, problems of assuming linearity. All those, after we have had lessons on those, it is appropriate time to move on to the machine learning, because machine learning is used in prediction. Many of the large companies like Walmart, Amazon employ machine learning to make predictions on their sales, to make predictions on their sales revenue, to identify the customers to target. All this kind of thing is done by machine learning. So it is appropriate time to start machine learning. So what exactly is machine learning? The first thing one should know that this is based on the notion that machines can learn. So machine learning is the science of programming computers so that they learn from data. That is the basic simpleton definition of machine learning. Machine learning has many aspects. Two broad categories of machine learning are supervised learning and unsupervised learning. Within the supervised learning, we have instance learning and we have instance-based learning as well as model-based learning. So when we are talking of regression analysis, prediction through regression model, we are talking of supervised learning as a model-based analysis. So let's start with that. Now we're going to start with, here I have already made the importations to start this. So the importations are usual, numpy, panda, and for step in the prediction, we have to do visualization. The main steps of prediction in machine learning are loading of the data, visualization of the data, fitting the data, which is also called training the data, and make the prediction of the data. So because of that, we need visualization. I have import plotly so that we can see interactively by hovering over the dot what we are talking about. And the model here is, see, note here, we have scikit-learn that linear model, import linear regression. We don't have stat models as previous. Now it is from scikit-learn that linear model, import linear regression. And here I have data. This is usual, just car names. I am going to predict the revenue of a car dealership on the basis of car sold. How many cars have been sold, and with the price of the car, how much revenue is generated. So for that, I have car names, I have prices in thousands, revenue in millions, and the inventory in thousands. For this simple process, a gentle introduction to machine learning, I am going to start with predicting the revenue on the basis of the prices of the car. Okay, so that is simple. And in the following lessons, we will have multiple regression where we will do vectorization, RMSE, root square mean error, as well as mean absolute deviation. all those kind of complex situations will come, but this is just a gentle introduction. For that, I have here same PD data frame data, and I just add this line to sort the data alphabetically, and I showed you the tails, 5 tails. So I have car name, prices, inventory, and this. So let's begin predictions with load the data. We did. Second step is visualize the data. Visualization. So visualize, L-I-Z-E, the data. Okay. So for that, let me just make sure you see this. So I'm going to do this markdown, visualize the data. Okay. So to visualize, I want to make sure you are seeing this. To visualize, let's define the x and y variables. So x equals df. What is the going to be? The x variable is going to be prices. Prices in thousands. Make sure you are writing the exact name of the color, okay? Of the column. Prices in thousands. Yes, that is exact. And second, the y variable is going to be, y is going to be df. What we're going to visualize? Revenue in millions. So make sure that is also correct. Revenue millions. Revenue millions. Okay. So once we have done that, let's write the figure code. Fig equals px dot scatter. We're going to do the scatter plot, which requires data frame, data from data frame, x equals prices in thousands, prices in thousands, comma, y equals revenue in millions, revenue in millions, and hover data. Hover, we would like to hover to see the value. Hover data, not dash, underscore. Hover data equals car names, okay, and let's comma and come down in the next line. Here we're going to do trend line, make sure no typos. Trend line equals OLS, so that we can hover over the trend line and see the regression line if we wish to do so. And labels equals, let's put the labels on. So it is going to be revenue in millions, revenue millions. This we're going to write exactly as it is, millions, revenue millions, colon. Here we're going to call it sales revenue. These will be shown in the axis, okay? Sales revenue in millions, and another one, comma, another is prices, okay? Another is prices. Let's write prices in thousands, and which is going to be sales price. Okay, sales price. That will appear in the x-axis. Revenue will appear in the y-axis. Okay, once we have these labels, let's go and fig that update. I'm using this update traces to add some more styles like marker equals dict. I want to add size equals 15 just to show the dots a little bigger. That's nothing more than that. Size equals 15. Fig.show. Fig.show. So let's look at this figure and see how it appears, what the trend shows, what is the slope. Shift enter. Okay, df is not defined, which usually means we need to restart the kernel. Press start of the kernel. Kernel might still running, so just be patient. Yeah, it just arrived. Okay, here you can see the trend shows according to the theory, higher the prices, lower will be the revenue, and prices has inverse relationship, negative slope, which is according to the empirical theory that prices decreases the sales, right? Hence the revenue. So that is showing it. So just hover here, you can see Volkswagen car has a price of 147,000 and a sales revenue of 111 million. So that's how we can see. And if we look at the regression line, you can see here regression line is also according to the theory. See, the slope is negative, minus 0.1838 times prices plus 123.1, which says that even if there is no, the baseline benchmark sales will start at 123 millions. When x equals 0, that means predictor variables are held at 0, we will still have sales of 123 millions at this dealership, car dealership. Okay, so the trend line is according to this line, we can see that. Okay, so once we have this, we have loaded the data, visualized the data. Now let's go ahead with prediction. So now prediction includes the training of the data as well. So let me just start with the commenting prediction of revenue. Okay, so that is the prediction of revenue. Let me make it a markdown so that you can see this line better. Okay, prediction of revenue. Let's go ahead and start here. As I say, this is a gentle introduction to the field of machine learning. So we're going to start with just one predictor and one response variable. So here we're going to write model equals linear regression that we have from scikit-learn, as you show in the importation line. Okay, model linear regression. Now model dot fit x dot reshape to ensure that the labels of column and rows are not included, right? Label dot reshape going to be -1, 1, and the variable y variable here. Okay, and now prices to predict revenue. I'm just creating this variable. Predict revenue equals np dot array. Okay, usually prediction is done for single item here, but I want to show you a multiple item is also possible. That's why I'm going to pick 15 comma 20 comma 25 comma 35 comma 50. Okay, these are 5 points we will predict. Okay, so now let's define the prediction. Prediction equals model dot predict how prices to predict revenue. Okay, prices to predict revenue dot reshape to ensure we're going to not include the labels. Reshape, and here with this technique minus 1 comma 1. Okay, reset. Now let's print this. Print. I'm going to just write a title. Okay, before showing the result I want to write the title. Prediction of revenue from car sales. Okay, it's always going to be in millions. Okay, that's just the title, headline, title. And let's go ahead and here. Now let's put the car names, because we would like to predict which car sold and which car generated the revenue. Car names equals, let's write a list. Dodge, comma, second is going to be Maruti. I don't know if this car exists, but just Honda, Hyundai, and Toyota. Okay, these are the cars that will be sold and the revenue will be predicted on the basis of their sales. Okay, so to display that, for name comma prices comma product, predict, not product, predict in Jip, we're going to use Jip method here to pair car names, comma prices to predict revenue, comma prediction, Okay, let me just, there is some error here. Okay, prediction, PREDI, see this, prediction, CTION, prediction. Make sure there is no typos. Prediction. Okay, make sure prediction prices to revenue, prices to predict revenue, and car names. Okay. All right. For that, let me just now print statement. Print f string. Okay. Let's do name 25s, just giving some space. Close. Prices. Let me just make this p bigger. This is a label, not variable. Prices. Colon. Now is the variable. Prices. Okay, prices colon 0.6f. Close and close the bracket as well. Okay, now let's predict. Let's go ahead and predict revenue. Okay, this is just a label. Predict revenue. Okay, a variable. Predict 2 decimal places. 0.2f. Okay, and close the bracket and that. Okay, so if there were no typos and things, I should get the prediction by these cars. Okay, there will be 5 cars, their price, and the sales revenue they generate. Shift enter. All right, there is a typo, linear regression, not something else here. W is extra here. Linear regression. Let's go ahead and run again. Series of text had no attributes. Reshape. Okay, so what does that mean? Okay, what that means is here I need to put the series, I need to make them data frame. For that I need to put the word value in this. Okay, where is this? Where did I define x and y? Here. That value. Okay, this should be values. Okay, similarly this one, values. All right, now let me run all of this and I should be able to get the results that I need. Okay, run all this. Yes. So if there are no more errors, this should give us the result. Okay, so waiting for the result. All right, car names is car names. Oh, COR here. You see the another typo. Car names is not core names. Okay, let's run this again. Shift enter. Okay, see here. Now we got, after all those typos, now we got to our results. See, now we can prediction. We get this prediction of revenue from car sales in million. Dodge, we sold prices of 15,000, predicted revenue is 120,034. Maruti predicted revenue 119.42. Honda predicted revenue 118.50. Hyundai predicted revenue 116.67. Toyota predicted revenue 113.91 in millions. So as you can see, we made the prediction of these cars. This is how large companies made predictions. This is based on this trend line. You see, the trend line shows that price and revenue has a negative slope. So you can see as prices rise, the revenues decrease due to the lower value, lower volume sales. Okay, so you can see prediction is done through machine learning. It is a very, very powerful. Machine learning is called, has data pipelines, which is a component of data manipulation. Machine learning is very powerful in doing this. You can see if you compare this with stat models regression, here you don't see any regression results here. You don't see any explanation of regression results. All you see is prediction, purely prediction. So machine learning is powerful in predictions. That's why the world is using machine learning for predictions, for aspects like spam diagnostics in emails, machine learning. For targeting sales products, machine learning. All these ideas are powerful in machine learning, which has a strong data pipeline for data manipulation, large data manipulation, as well as transformations. That's why machine learning is defined as the science of programming computers to predict on the basis of data. They learn from data. Machine learning, programming teaches from data. The more data we feed, the more lessons we predict. So it is a very powerful. In the coming lessons, we'll be dealing with much more realistic examples of multivariate analysis, prediction on the basis of multivariate, which will require calculation of root mean square error and all those things, as well as linear algebra, vectorization, all these representations. That is coming on. So thank you for listening. Thank you for watching. Please subscribe to my channel for more data analysis, machine learning, statistics, Python, and pandas. Please subscribe to my channel. Thank you for now. See you. Bye-bye. Next lesson will be coming soon. Thank you. Bye-bye.